2 gear shifts, and you had a lot of
ATHS convention,
not only did it require
Madison, Wisconsin,
skill in shift to transmission effectively,
demonstrating the working principles of a 12.513 Road Ranger transmission by Tony Martin.
So different people had different ideas. Mac had their duplex, triplex, quadruplex that was a compound transmission, had a main section with an auxiliary section on the back. That solved the length issue to a certain extent, but you still had the 2 gear shifts. So in the early 1960s, Fuller came up with their Road Ranger idea. And Road Ranger referred to a design of an air-shifted range system where you had a closely spaced main transmission. The ratios were closely spaced. Then you had a high and low range to shift between those. So that would give you 10 speeds that you could shift with 1 gear shift and a button to pull up and push down and go from high to low. So that was the R96. It was a single countershaft still. And I'll kind of explain what I'm talking about with countershaft here in just a second. But it was a single countershaft, torque was limited. Still, they were quite successful because drivers really liked the idea of having 1 gear shift. So throughout the 60s, engine horsepower was increasing and there was a horsepower race going on. And to combat that, somebody had to have a stronger transmission. Fuller came up with the idea if 1 countershaft works, 2 will work better, and we can split the torque up. So this transmission has, as you can see here on each end, these are countershafts. Main shaft in the middle. And this splits the torque. I'm going to pull the top off in just a second and show you kind of how the torque flows through the transmission, but you can kind of see what I'm talking about. This transmission is wider than it is tall. Single countershaft transmission, you can always tell it's tall, but it's narrow. So they spread it out. It made a very compact 10-speed transmission. They got the idea of adding a deep reduction range on it, and they call it a 15-speed. That was great, but the place that they couldn't compete was with the close ratio splits that the Spicer auxiliaries had. So in 1967, they came up with the RTO 913. That was a 5-speed main with a 3-speed auxiliary section, and the auxiliary section had a splitter gear, which gave you roughly a 200 to 250 RPM split with just a touch of a button. You didn't have to move the stick, and it gave you 13 usable gears. That caught on very quickly, and by the early 1970s, probably 75% of the trucks that were built had a 13-speed transmission. So that's what this is. Your slave valve, your Road Ranger valve, they would call it, bolts right here on the side. In my infinite wisdom, I took that off and cleaned it and left it at home. So you can just imagine what it would look like. You have to use your imagination here. Or Google it. You can even Google a picture of it. They're all the same, or they look the same, function the same. So this is the main box. This transmission is made up of 2 basic sections. This is the main, and this is the auxiliary. So we're going to talk about the main first. And this is a shifting top. Whenever you look at model numbers, a lot of times on the sticker, it'll say RTF 12513 or RTOF 12513. All that refers to is this shifting top. They move where the gear stick goes in and move it forward. So the F-Series has this move forward, no letter is back here. It just makes it a little easier in a conventional application to, if you move the stick forward, to not have to have an offset in your gear stick. So we're going to pull the top off, shifting top. These are your shifting forks, and I'll show you what they engage here in just a second. But as you move your gear stick up and down, you can see that the fork's moving a little bit. And here on the inside, you've got 3 little gates. And here on here on the reverse, see a little tab that sticks out. When you start to put a Fuller transmission in reverse, a road ranger transmission in reverse, you know there's kind of a little spring-like feel that you have to overpower when you put it in reverse. That's what you're actually doing, is compressing that little tab right there to release it so you can put it in reverse. Now, flip this over on the side. There we go. Yes, sir. So, this is the inside. This is the counter shaft, and there's another here in the bottom. On a direct transmission, you'll notice when the main box is direct, I'll say that, you'll notice the gears get progressively smaller all the way down. When you have an overdrive main box, the gears will get progressively smaller, and these two will be in reverse positions. This one will be small, and then you'll get bigger again. Here's why that is. When you turn the transmission, this gear is not connected to anything back here. This gear is only connected to the input shaft. It is what is called, this gear, called the main drive gear, also turns your two counter shafts. So as you're spinning it, it's causing the counter shafts to turn. And if you notice, each one of these gears is turning at a different rate. That's because they float on the shaft. They're not actually attached. This is a main shaft. This is what's here in the middle. And this is a main drive gear. So we've got that. This is the front. Look. So this obviously will not even close to fit. So there's a collar inside that holds it in place, and this slides. It's splined on the shaft. It splines, and whenever you shift the gear, this collar slides into that gear and engages it and makes this gear turn your main shaft, going out, putting power out the back. So when you actually are shifting gears and move the stick, the grind that you feel if it doesn't go in quite right is this collar trying to engage this gear. So that's
So is the collar the only thing I'm moving when I...
Yes. The only thing that moves is that collar.
You chew off the edges of the teeth when you're trying to get it in?
Absolutely, yes. This one is actually reasonably good, but you may be able to see these kind of come to a bit of a point. When you have one that has been ground and not put in gear smoothly, it starts to wear it round. When it wears round, it also wears the inside of this gear round. Fuller called these clutching teeth, meaning with the shapes that they have, they want to go together. So when they start rounding off, they don't want to go together, and it pops out. This is what that counter shaft looks like. That is a lot of gears. It's pretty heavy, but you've got as you can see here, your corresponding gears. You've got reverse, first, second, third, fourth, PTO drive gear, and fifth.
Where's the PTO?
PTO would go either on the side.
What gear?
Oh, the next to the front. Next to the front. And although they look the same, there's a different number of teeth. There is a left and a right, or an upper and a lower, however you want to refer to it. One drives a side mount PTO, the other drives bottom mount PTO. So all of these gears press on with the exception of reverse and first. So if you have one of these damaged, you can actually press this counter shaft apart and replace the one gear. If you have a direct and you want to convert it to an overdrive, You press these 3 gears off, put this gear in place of this one, put your PTO back on, and put this gear in place of this one, and you've made your front box an overdrive. You hear a lot of people talk about turning a transmission around. That's what they're talking about. They're switching those 2 sets of gears in there. So that's a countershaft. That's what's spinning. So as this spins, all these are turning the same direction except reverse. Reverse has an extra idler right here. There's another that corresponds in the bottom, which makes this gear turn backwards. Adding an extra gear in the train makes it turn backwards. So when you shift it, it just pops in, and now you may be able to see the auxiliary drive gear, which is here at the back. It's turning now. When you take this out, it might turn, but I can hold it. So whenever you're sitting here with the truck in neutral, the shaft is spinning, this auxiliary drive gear is stationary. Then when you mash the clutch and you put it in gear, you're gonna shift it into low. So you go here, and that one doesn't want to drop in because it's low, it doesn't have much wear. It'll drop in. Then when you shift, that one comes back in the center, this one drops in, then this one drops in, all the way till you get to high. With a direct main box, which will be an RTO 12.5, 95.13, an RT 10 series, RT 15 series. When you put it in high gear, you move this collar to the front. What you've effectively done when you move that collar is you have connected this shaft to this shaft. You're no longer using your counter shafts. That was a great design to increase the capacity of the transmission, because you're not relying on anything but the strength of that main shaft. When you have an overdrive, you're not doing that, because you're having to use your counter shafts to speed the transmission up. So even though in overdrive you get a little extra speed out of it, and theoretically they're the same torque, it's just not quite as strong. So that's the main section, and you're turning this auxiliary drive gear. That's what I'm talking about. This is a very important piece. As you can see, this is the end of the main shaft. It's splined to it here, so it's driving on that main shaft. And you can see this is really polished on the outside, and you can also see there's some clutching teeth inside, just like those collars are on the main, and then it's got teeth on the outside. That drives this auxiliary box. So whenever you're in low range, these outside teeth are engaging these, and you're spinning this, and it's at a reduction. That's when you're in low range. When you shift to high, for my air nozzle here just a second, you put air here, and this pops forward. When that pops forward, you can see these teeth inside here, which are a little better seen on this piece. Engage this to create a direct drive that couples the back box directly to the main box, so torque is flowing straight through the transmission again. That happens because of this piece, synchronizer. I'm sure some of y'all have driven a truck that when you shifted from low to high, there was a crashing sound, grinding sound. That's because the synchronizer was getting worn. If you notice, there's a lining on the outside here and also on the inside. So this lining contacts this drive gear to synchronize the speed, thus being called a synchronizer. Synchronizes the speed, lets the collar snap in, and no sound. When the lining is worn off, this goes in place, but it's not actually synchronizing the speed. The clash that you hear is this gear slamming into your auxiliary drive gear. And when that happens enough, you wind up with an auxiliary drive gear that looks something like this. That the teeth are chewed off, and it's actually started wearing the inside where it splines on the main shaft. This gear came out of a transmission that the gentleman had run for so long, it no longer had high and low range. It wouldn't stay in either one, and he was pretty much stranded. Instead of a simple synchronizer replacement, he needed an auxiliary drive gear as well. So on a 13 speed, we have a 3-speed auxiliary section. 5 in the front, 3 in the back. That doesn't add up to be 15. Well, you don't use low gear in the front with direct and overdrive in the back. So that comes to your 13.
Is that the same principle as a Brownie when they used to say you could only shift first and second and low in the auxiliary
because if you went repeat gear.
Right, because if you went to third, you'd blow the transmission.
Yes, sir.
Yep.
And that's what happens here. You can physically put your transmission in direct or overdrive and in low gear here, but you're winding up with a deep reduction here, a strong reduction here, with an overdrive here. For short distances with virtually no throttle, you can get by with that. As soon as you start to apply some throttle, you will have very serious problems because this reduction doesn't work well with this over gear. That you're slowing it down and you're speeding it back up, and they didn't mean for you to do that.
Right.
So that's how a 13-speed back box is. And if you notice, the counter shafts for a 13-speed look kind of like barbells. And that's because here on the front is what contacts your drive gear. In the back, you have another gear that is your overdrive. That's your splitter. The 13-speed overdrive is in the back box, not the front. So, same sort of principle as the air shift here, pushing it from low to high. There's another cylinder here on this corner that uses, you may be able to see it, there's another shift cylinder coming in that shifts direct and overdrive. When you shift the 13-speed to overdrive, this turns 1 revolution to every 0.87 revolutions that this turns. So that gives you your over gear. This shaft is no longer connected. When you go back to direct, the shaft is connected and you're 1-to-1 from the input shaft to the tail shaft. You've eliminated every other gear in the transmission. You're only using your main shaft and your main shaft in your auxiliary section. That's a 13-speed. Now, I didn't bring a 15-speed, but I'll show you here. If you notice how this back box, first off, is deep. On a 9 or a 10-speed, it's shallow because you've only got 2 gears involved. You got a low and a high. 13-speed and a 15-speed and an 8LL, they're thicker like this. They're 3 inches longer because you've got the extra set of gears in the auxiliary section. A 13-speed has this little bump coming out. So if you just walk up to a random transmission and there's no tag on it, if it has that little bump on the back case, it's a 13-speed. There's nothing else it can be. So with the 15-speed, you have a counter shaft that looks like this. This part is just like the 13. It engages up at the front. You got your same low reduction here, but then you've got an even smaller pinion drive gear here that's going to drive a huge bull gear in the back. That's your deep reduction on a 15-speed and an 8LL. With a 10-speed or a 9-speed, it looks just like this, minus the section that I'm holding my hand over. You only have two. So essentially there are two different main boxes. The 13-speed, 9-speed, and 8LL have a low first and reverse, then a equally spaced second, third, fourth, and fifth. A 10 and a 15 have reverse, and then first, second, third, fourth, fifth are all equally spaced. The drawback to that is you lose a little on your first gear. First gear in a 10 is not as low as first gear in a 9 because they use the deep reduction main box. Then the rear section, there are three as well. There are two different 3-speeds. There's the 13-speed, which has the splitter for the overdrive. Then there's the 15-speed, which has the deep reduction, and that's the same basic idea that's used on the 8LL. You can actually take a 9 or 13 main box, put a 15-speed deep reduction back box on it, and have an 8LL. Maybe all the part numbers won't match, but nobody can drive that and tell it's not an 8LL. The ratios are very close. Some of the 13 speeds, they had a double overdrive, an RT00. That's where they had an overdrive in the front. They also had their overdrive in the back. So thus giving it a double overdrive. I'm sure some of y'all have heard some super truckers tell about the double over 15 speed that they had. I'm still waiting for somebody to show me one because there's no way to get two overdrives out of a 15 speed. You got over in the front, you just saw there's direct, low, and deep reduction in the back section. There's nowhere to get the second overdrive from. The only difference when you have an overdrive main, your last two gears are reversed. Instead of high gear being back, since you switched the two gear sets inside, high gear's now to the front. That gives you an overdrive front, no overdrive back. It's a 15-speed overdrive. Just because the gear shift goes to the dash when you shift it in high doesn't mean anything. They all do that if they're in overdrive. This is a 12.5 series transmission. In the early 80s, they decided to increase capacity and cut down on noise. They would go to a fine tooth pattern, and that would be the 11.6, 12.6, 14.6, eventually 15.6. On all of these teeth, you can see they actually have a flat tip to them. If this was a fine tooth transmission, you would not have to count the teeth. You could actually look, the teeth would come to a point. The idea being, as they turn, with the coarse tooth, you're only getting a couple of teeth that are meshing at the same time. With the fine tooth, you're getting partial engagement, full engagement, partial engagement again. You're getting more tooth contact for less wear, less noise. This transmission, you would want to run 90 weight, 80 W90 gear oil in it because of the coarse teeth. You need the thick oil for the cushion. With a fine tooth transmission, you want to use a 50 weight transmission oil because that thicker oil will actually make it a little more difficult to shift and generate more heat than with a thinner weight oil. A few things to consider on these transmissions. You may notice, may not notice, here on the input shaft, it's really chewed up. Your clutch disc actually slides right here. This is a pilot bearing that goes in the flywheel right here, and then your clutch discs are sliding here. When you're